Hello and welcome to this video on simplifying, evaluating and solving equations involving logarithmic terms. So in our first expression here, we can see that we've got two terms involving logarithms, and what we must notice is that they both have the same base, that's 6 in this case. And that's good news for us because it means that we'll be able to combine these two log terms into a single log term. But before we go ahead and do that, we're going to focus our attention on the first of these terms, and in particular the half that is multiplying in that first term. Because when we're working in logarithms, one of the things we're able to do is rewrite that half not as a multiplier in front of the term, but as an index on the 9. And remember, it is an index on the 9, not on the whole log term. The second term is unchanged at this stage. We'll get to that later. But we can go a little bit further with that first term if we remember that anything to the power of half is in fact the same as the positive square root of that anything. So 9 to the half in our case is the same as the square root of 9. The positive square root of 9 is of course 3. So we can simplify that first term even further until we get log 3 to the base 6 plus log of 2 to the base of 6. And now we're at the point where we want to try and combine these terms together. Now, as I said before, the base is the same and we're adding these two terms together. And when we're adding them together, then we're able to write a single log term where the 3 and the 2 there will in fact be multiplied together. So we will end up with log of 6 to the base of 6. And again, we want to remember another little rule or fact that we have with logarithms, and that is that the log of anything to its own base is in fact equal to 1. So in our question, log 6 to the base of 6 can be finally evaluated, so we found its value, and its value is in this case 1. Now we have another example here of solving an equation involving logarithms, and again it's worth noticing that the base is the same. That will allow us to combine these terms. And in this case, there's nothing we can do to simplify either of the terms. What we do want to notice is that we are subtracting here. And when we're subtracting two log terms, well, we can write them as a single log term, this time where we're dividing. So in this case, we'll have log, the base is unchanged, and we end up with 2x plus 3, all divided by x. And it's the divide because of the subtraction that was earlier. Now we should really put this in brackets just to make it clear, and all of that equal to 1. Now we might think, what do we have to do next? And what we have to do next is take an anti-log. We have to undo the logs, and we do that using a process called exponentiation. You may have heard of exponentials. Essentially that's what we're doing, an exponential type operation on both sides of this equation. Now what that does is leaves the 2x plus 3 over x on its own. Notice that the log to the base 5 has disappeared, but what's worth noticing is that the base was 5. Now that 5 doesn't really disappear, it reappears on the other side of our equation as the base, and our value of 1 that we had on the right hand side, well, that now becomes an index on the 5. So you want to just think for a moment that the base of 5 when we had the logarithmic term has now become a base of 5 in this little exponential term. And we've effectively got rid of the logs, which means we can solve this using normal rules of algebra. In this case, multiplying both sides by x. We'll get rid of that denominator of x. And then we want to think about subtracting 2x from both sides of this equation. So 3 is going to be equal to 3x, and I think we can then simply solve to say that x must be equal to 1 in this case.